Now, in previous example, I have explained what is tree, then types of binary trees, and what are the terms used in the trees. Now, in this session, I am going to explain how the tree is represented using an array, that is array representation of the tree. A tree can also be represented using an array, which is called as an sequential representation or array representation. Here sequential means the arrays always will be in the sequential form. The memory is always in the continuous form. Therefore, it is called as an sequential representation or array representation. Here, some of the point related to array representation are, what are those very important points are: the node are numbered sequentially from 0, and the node with position 0 is considered as the root node. That means the node here will take this one as 0, next 1, next 2, next 3, and next 4. Therefore, the node are numbered sequentially from 0, and the node with position 0 is considered as the root node. And if any index 1 is 0, it gives the position of the root node. If the given position of any other node in I, that is 2i plus 1, gives the position of the left child, and 2i plus 2 gives the position of the right child. Now you assume that I am giving a value I equals to 0, then 2 into 0 is 0 plus 1, only one node is there. Therefore, what does it means? It gives the position of the left child. That is, I have told that we should begin always from 0 and its value is 1. Therefore, it is in a left child. And if I put I equals to 0, 2 into 0 is 0 plus 2, and it gives the position of the right child. Here you can see this is called as 0, 1, 2, 3, 4, 5. You got it now? 0, 1, 2. Next 3, 4, 5, 6, 7, 8, 9, 10, and 11. Here you can see if I is the position of the left child, then I plus 1 the position of right child. Here you can see this is I. Here I put I equals to what? Here you can take this one is 0. Now this is 1. Now I equals to 1. Then plus 1. What? 1 plus 1, it is equals to 2. This 2 is nothing but here t. This is the position of the right child. Now if you assume that I am in t, now I want to the position of e. What I should do? I should decrement 1. That means I should subtract 1 from the right child. That is, if I is the position of the right child, then I minus 1 gives the position of the left child. Here you can observe. Then given the position of a node I, the parameter position is given by I minus 2 whole divided by 2. That means I am dividing all this by 2, that is parent position. Sorry, I spelled wrongly. The parent position is given by I minus 2 whole divided by 2. See, here you can take. If I is odd, it points to the left child, and if it is even, then it points to the right child. Here you can see the example. If I divide by it 2, it will give the position of what? Parent node. Now let us assume I will put I equals to 4. If 4 minus 2, that is 2, 2 divided by 2, that is 1. That is, here you can observe, that is 1 is the parent node of what? Y. Next, to represent a binary tree using array, first we need to convert a binary tree into a fully binary tree, and then we give the number to each node and store it into their respective locations. That means here in previous diagram you have observed that it is not an a what fully binary tree. Now what I should do, I should convert that into a fully binary tree. That means in previous diagram you have observed that there is a missing of left child and some other node, it is right side. For that I should add left child and right side to make that diagram as a fully binary tree. Now let us take an example to understand how to represent a binary tree using an array. See, now you can see here, this is a binary tree, but it is not a fully binary tree. Why? See, I will explain. You can observe D is a root node which is having two child, that is E and T. Now E is became in a parent node and T is also became a parent node for below nodes. Now in left subtree, here E parent is having only left Y child, but in the right side it is missing. Similarly, in Y, what happened? This parent node is having only right child and missing left child. Similarly, when observe T is having both childs, that is K and S, but in K what happened? It is missing right child node. In S, it is missing left child node. Now to make this one as complete binary tree, I should add a node that is right child to the E and left child to the Y, and similarly right child to the K and left child to the S. Here in the above example, to convert binary tree into full binary tree, we need to add nodes that don't have child nodes till the last level of the tree. This is the last level. I have told that here the nodes what are missing and where I should add the nodes. See, here you can observe carefully. See, it is missing. Here I should add. That means the last level should be same. Now see, here I have told that he is missing right child. For this right child, once again other two child are missing. That is here left child and right child. For this I am adding how many? Two nodes for this one. Totally right child 3, I need 3, and here one is missing for left, that is for Y, and similarly for K it is missing one right child, and for S it is missing one left child. So now the tree becomes as a fully binary tree when we add these childs or these nodes. After that, to represent using an array, we need to give numbers to each and every node, but level by level. I told that we should go on giving the numbers. That is, we should always start from here. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. See, and I have missed one. 1, see, observe this is carefully because numbering is always very important. I have said that we should always begin from 0, that is 1, and left to right. Here see 1, initially we have taken 0, for that reason it came 14. Now here what happened? I have begin always from 1. Here I have begun with 1. 1 is a root node. This two nodes is having one left child and one right child. that is 2, 3, and similarly this 2 is named as having another 2 childs, that is numbering as 4 and 5, and this t is also having another 2 childs, that is 6 and 7. Now this 4 is having 2 childs, that is 8 and 9, and similarly this 5 is having other 2 childs, that is 10 and 11, and this case is having another 2 childs, have numbering, that is 12 and 13, and this last one is as it is having 2 levels, therefore 14 and 15. Now you can observe what is the level: 1, 2, 3, and 4. The level is for this tree, complete binary tree, is 4, and depth is also an a 4. After giving number of each every node, now we have to need to create an array size of 15 plus 1. See, you can observe this 0 to 15. This is a continuous memory allocation. Here 0 represent the what? Root node. After the store each node, one node in array in their respective index point, like D as number 1, then we store it in the array at index 1, and E is as number 2, then we store it in index 2 in the array. That means 1 represent what? Left, and 2 represents the right. See, similarly you can observe the tree how it is represented in a array of structure. See, 0, 1, 2, 3, 4, 5, 6 up to 15. Now, important terms to represent a binary tree into in a sequential order. What are those? The root is always stored at index 1 in the array. If any node is stored at k position, then the left child of the node is stored at index 2k, and the right child is stored at the index 2k plus 1, and the parent of the node is stored at floor k divided by 2 index. Initially, in previous slide, I have taken the term as I. This is I position, and this is 2i for right child, and 2i plus 1 for parent child. To get parent child, I am doing dividing by 2, and for right child, what I am doing? 2i plus 1. For left, I am taking 2i. In previous slide, I have explained. Note, the size of an array to represent a binary tree of height h is equal to the maximum number of nodes possible in the binary tree of height h. Now, you can observe the program carefully. I am taking a binary tree using array. First, I am declaring an what is this? A structure node, that is empty node, and I am inserting values into a node. Here you can observe initially what I have taken the tree node as a null. If it is null, then I am allocating a what? Memory to a tree node. After that, tree of left, I am inserting a value c comma 2n plus 1, that is what? Left side. This is for left child. Then tree of data c of n, that means data the item to be inserted at node, and now I am connecting to the right child, that is c of 2 into n plus 2, that is I plus 1 and I plus 2. In previously have said, as I said. Now after inserting, what I am doing? I am returning. This process will continue where until a new or a null is entered. For null, we are pressing what? Enter key. Now it will travels in the order. How? In order. Now it will always move from left to right. I have said if tree is not equal to null, then we will move in order tree of left, and I am printing the data which is in the that tree, and I am moving to the next right tree. Here you can see there is a travels. There are three types: in order, pre-order, and post order. Now here we need an in order. For how it will work from left to right. Other tools I will tell in upcoming sessions, that is pre-order and post order. Now you can see I have inserted these elements, that is A, B, C, D, E, F. Then I am pressing enter. Then G. Next I am entering the values, that is enter keys, that is null values. After that I am inserting into a tree. Then I am traversing, I am calling this function, that is in order, that is tree. Now the values will be go on implemented, that is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 and 21. Thank you.